Fluids, pressure, and the atmosphere. Some questions to ponder. What direction is pressure applied to an object surface by a fluid when it is submerged? What can be said about the pressures in a fluid at the same depth? Why does the atmosphere apply pressure? Pressures from fluid in space. Let's start off by leaving Earth because gravity and the atmosphere will play roles. So to get the true nature of a fluid pressure, let's go out in space for a second here. When we do go out in space, if we had a cylinder up here filled with a fluid, and then within that cylinder we had a block, what we'd find out is on all sides of this block, the block would feel a pressure, and that pressure would be perpendicular to its surface.
Are you ready for the first portion of my act? I'm in a box!
So another contradiction today. A screaming mime.
Oh! I didn't even think! There's a lid to the box!
It reminded me of my starburst. Starburst makes no sense either. It's a solid, yet juicy, like a liquid.
By the way, I am a mime!
Starting to hate screaming mime.
I accept change! I accept bills!
Now let's get down to Earth. On Earth, gravity causes pressure to vary with depth. And so we would still have the pressure all around the block here with this cylinder filled with fluid. But now gravity plays a role here. So as gravity is, as the object is deeper and deeper within the fluid, gravity's effect for this given depth, h here, is that the pressure gets greater and greater. So the pressure as you go down the side gets greater and greater, and the pressure at the bottom is going to be greater than the pressure at the top. The pressure still is perpendicular to all of the surfaces. So, objects that are submerged in a fluid feel a pressure all around them from all sides coming in perpendicular to all of the surfaces of that object. So, our next idea, thinking about it, we live in a fluid here, this fluid called air. And there's a lot of it, especially if you consider that air goes all the way out until you get to space. So, is there pressure from this fluid called air? Yes, in fact, there's a lot of pressure from that fluid called air pressure. And in fact, in 1 square inch, which is about this much, in 1 square inch, there is about 15 pounds of force on that square inch. Actually, 14.7 pounds per square inch is what the atmospheric pressure is down here close to sea level. So, that being the case, if this is a square inch and that covers about my fingertips like that, those 2 fingers right there, to feel that force in that area, I'd have to take this weight and I'd have to hold up this weight with just those 2 fingers, if I can do that. Whoa. And that's an awful lot. That's an awful lot of pressure, an awful lot of force for that small area. So, if I then take that idea and I take a bunch of these, this is about 2 square inches, and if I have, and I measure my hand, the area of my hand, I have 1, 2, about 2.5, then 3, 4, another half, so that's 5, and about 6, 7, and the area of my thumb about 8 square inches. Let's say that my hand is about 8 square inches of area. So 8 times 2, because that was 2 square inches per each of those pieces of paper, at 16. 16 times 14.7 is 235. 235 pounds. So if I hold my hand like this, I'd be holding 235 pounds of air. Wow. That doesn't make sense unless you think about it. The air that I'm holding is all the air above my hand, all the way to outer space. Wow, the whole thickness of the atmosphere I'm holding in my hand here. 235 pounds. Well, Mr. Bemke, how can you be holding 235 pounds with just your hand like that? And the answer is the air pressure on top of my hand is really the same as the air pressure underneath my hand. So though there's 235 pounds per square, 235 pounds of pressure on my hand here, there's 235 pounds of pressure underneath my hand, 14.7 pounds per square inch. Since those forces are equal and opposite, the net force is equal to 0, and I don't feel anything. So why don't we feel that 14.7 pounds per square inch all over our bodies? And part of it is because the air pressure is the same all around our whole body, and so those forces tend to neutralize from side to side and top to bottom and all around us. And our body actually has equalized with that pressure. Our internal pressures of our body have equalized with that atmospheric pressure and stabilized to keep the net force equal to 0. So when we go to high altitudes, for example, we do feel a variance and our ears pop and that kind of stuff, either if we're going up to a high altitude or down from a high altitude. We may feel that sensation of our ears popping or not quite feeling right, and that's where our bodies are equalizing for the pressure that we are existing in. So, our atmosphere, quite a bit of pressure. In fact, 1 atmosphere is the way we measure atmospheric pressure, and its symbol is ATM. And 1 atmosphere of pressure is 101,300 newtons per meter squared. Remember that a meter squared is quite large. And so this is a lot of force, but it is distributed over a large area. A newton per meter squared is called a Pascal. And so we have 101.3 kilopascals is also the way to represent this particular number. So 1 atmosphere, or 1 ATM, is on average the pressure at sea level. Weather and climate affect this atmospheric pressure, though, so it does vary. Altitude also has an effect on this atmospheric pressure due to the depth variation within the atmosphere itself, within that fluid. So as you get higher and higher, go up on a mountaintop, there's a lot less atmospheric pressure than there is down at sea level. There are other units for pressure, other ways we measure pressure. One is called the bar, and a bar is 100,000 pascals, which is approximately the same thing as 1 atmosphere. In fact, on the AP test, the constant for 1 atmosphere is 100,000 pascals, or 1 bar. So it's kind of the similar quantity. Also a similar quantity to 1 atmosphere is 760 millimeters of mercury. Hg is mercury, and this is an amount or measurement used in barometers and blood pressure readings and so forth. And we're going to see where that 760 millimeters of mercury comes from a little bit later. The torr is also the same thing as 1 millimeter of mercury. So 1 torr is 1 millimeter mercury. So 760 torrs is the same thing as 760 millimeters of mercury, which is the same thing as 1 atmosphere. And as we saw before, 1 atmosphere is equal to 14.7 pounds per square inch. PSI is used in things like tire pressure and in pressure gauges for like water pressure and so forth. So that's enough for now. When you close out of this video, go check it out. Go to YouTube and search Queen Under Pressure. And when you do check out their song Under Pressure, it'll give you something to hum when you go into the next video talking about pressure for depth. There are a couple more slides here, but I wanted you to check out Queen Under Pressure. It is kind of a weird video though. So Can you answer the questions? What direction is pressure applied to an object's surface? What can be said about the pressures in a fluid at the same depth? And why does the atmosphere apply pressure? And of course, Scratch has his parting idea here. And learning is all about continuous improvement.